Everybody, welcome. It's about a minute after 12 Eastern time, so I think we'll get started here today. I just want to say thank you all for being here today. I know I'm really looking forward to this mechanical session with our two mechanical specialists. I'll introduce them shortly, but before we get started, I just wanted to give everybody a few housekeeping items. Just so you know, we are recording the session. Because we are in webinar mode and not meeting mode, there is a box at the bottom of your screen that says Q&A. If you could please type in any questions you may have in the Q&A, and I'll read them out loud for Claude and Robert to answer. Just so you know, throughout the presentation, every 5 to 10 minutes, there'll be a slide that says questions. So there'll be a sort of a natural pause at that point where you can ask any questions that you may have to Bob and Claude. Also, very short poll at the end of the session. It's only 3 questions, should take about 20 seconds to answer. We'd really appreciate if you take the time to do that. It just helps us improve any events going forward. And with that, without further ado, I will introduce Claude Gagnon. He is our Director of Mechanical Services, and Robert Corfield, our Manager of Car Loading Rules. So Claude, over to you.
Great. Thank you very much, Janet. Hello, everyone, and thank you for joining Robert Corfield and myself to the Mechanical Lunch and Learn. It is important to both the railway industries and its customer, especially on open-top cars, that product be secured in a manner that will maximize damage-free transportation of commodities and ensure that safe railway operations are not compromised. Hope this presentation will provide you with a better understanding of the importance of a safe loading securement. I'm trying to, oh, there it is. Okay. Here's an overview of what we're going to be talking. Today, we will cover some safe and efficient loading and securement practices of product on rail cars. First, we will talk a little bit about the RAC history, about the rules and regulations developed by the Railway Association of Canada and Association American Railroad, the AAR, which are mandatory as per Transport Canada freight rules under the Railway Safety Act of Canada. We also participate at the AAR Open Top Loading Committee and also the Closed Car Committee on behalf of our members. We assist members and customers with developing new plans and modifying old loading plans. We do inspection of cars at the rail yards, customer sites, and also at the interchange. We provide open top load training to members, customers, and also contractors. On a new loading plan, we may request to have an impact test. We'll show you what's an impact test later on, or test field shipments where we follow our cars at origin and destination. We also assist railroads and shippers with securement, measuring loads and clearances for standard shipments and also dimensional loads. Bob, if you have a slide.
Okay, thank you. Morning, everybody. Bob Corfield here. I'm basically out in the West. I'm in Vancouver, British Columbia, and it's a little earlier here for me than for most of you folks, so bear with me if I nod off once in a while. Anyway, we're going to start off with basically how the loading rules came about, and what it was is the Code of Rules, which you see up there on the left-hand side mainly, was revised in 1901 and comprised of 68 pages. This was adopted from the Master Car Builders Association, or was adopted from the former Master Car Builders Association recommended practices, which is the one on the right there. It was established to prevent damage to rail cars and promote safety. Created uniformity in loading patterns, enabling the ease of interchange between the carriers, and led to the development of loading rules as we have today. RAC was established, going one step further, back in 1917 to ensure the efficiency movement between railroads of troops and supplies during the First World War, as there were concerns regarding the loading differences of the major rail carriers, which caused delays in shipments. The government requested at that time that they work together to create common loading figures. This union was so successful that the RAC was established. Next slide. What we have here is an example of loading rule and why they're important. In 1947, Warrior Bridge, PA, which I would assume is Pennsylvania, 2 trains, 1 passenger, the other one a freight, were traveling in the same direction on parallel tracks. The freight train was moving at 5 miles per hour and consisted of 57 cars, which back in those days would have been a full-length train, which included 3 gondolas that were loaded with steel plates measuring 20 feet long by 10 feet wide and approximately 10,000 pounds each. The plates were propped up, as you can see in the photo on the left, by wooden stakes at an angle to reduce the width at some point. At some point, one of the metal plates shifted laterally and hung over the side of the car, following the adjacent track. As the passenger train passed the freight train, it struck the protruding plate in the gondola rail car. The plate sliced into the skin of the first car, which you see on the left. And the second car was filleted by the plate, as you can see by the right there. Unfortunately, 5 people were killed and 53 people were injured. Next slide. Today, example here is of the same style of load, but with modifications made to it. It has steel cradle, and you can see the tie-down rods on there. AAR and RAC worked diligently together, modified this figure, as you can see, and it can now be found in section 10 or figure 10 of section 2, which is the steel figures manual. Next slide. Here's an unfortunate situation that happened not that long ago. Lumber from an incomplete layer cored out, striking an oncoming train, which caused an unfortunate fatality. Well, this put a real halt to the movement of center beam load, so we had to act fast on this, and obviously we wouldn't want another situation like this. So we got together, we tested it, we used the VTU down in Pueblo. VTU is a vibration unit that simulates rail movement and so on and so forth. And we came up with a design of using compression bands. And the compression band for an 8-foot package, what you require is a compression band on each side of a 4-foot void. What our thought was that, you can get up to a 4-foot piece of lumber come out and you'd still be safe. But after that, it starts to veer out and then you'd have an issue. Next slide. Here you can see some coils starting to leave the cart at one end there. And loading rules are written to prevent accidents and to assist a loader in building a safe load. That has been tested and approved by the Open Top Loading Committee. And Open Top Loading Rules Committee consists of members from the railroads, AAR, RAC, as well as car builders and suppliers. Here's another photo of an unfortunate example of a loading figure doing what it's supposed to do. And that is the load staying with the car. 2 loads of poles rolled over at a washout at Sumas border, BC during last week's flooding. So that's pretty recent, that one there. Safety is a big concern in developing loading figures to be able to withstand normal rail operation and unfortunate accidents as shown.
If anybody has any question, you can ask them. Meanwhile, I'll show you some photos of when things can go wrong at the railway. But do not hesitate if you have any question.
No questions as of yet, Claude.
Okay. But you should know also, when there is a new project for moving different product, it will be really important to have the RAC mechanical group involved at the initial stage. We can assist members and customers to load product on the right type of car and assist with the type of securement that will be required to secure that product safely to destination. So as you can see, there's a lot of loads that they're incorrectly loaded, shifted, falling off from the car, and that's what we're trying to avoid by providing these training sessions.
Oh, we have a question, Claude.
Okay.
How many different types of cars are there rules for?
Well, we have all types of cars. We have rules for flat cars, gondola, upper cars, center beam cars. So anything which has an open top, there's no roof, we have rules for these cars, for these products. Hope it answered the question.
Thanks, Claude.
So we'll
We
move
have
on to the next. Sorry.
we have one more question, Claude. Is the shipper responsible for loading properly, or is it upon the railroad to ensure it is loaded properly?
Well, as per the AR rules and regulation, it's a both responsible. The shipper has the responsibility to make sure that they're loading as per the AR rules and regulation, and the carrier who is inspecting the load should know what are the rules and the loading plans. So they both are responsible to have a safe load. Bob, anything to add on this?
No, it's basically that way. It's really the shipper's responsibility to know how to properly load the car. We just do an inspection at the first inspection point to make sure it's correct, but it is basically the shipper.
Just for information, this car that you see on the screen, it's a load of aluminum ingots. Normally, there's supposed to be 6 ingots. And during this traveling through the Eastern Quebec, 2 of the ingots fell off the car during a curve, while being on the curve. So we lost 1 ingot, and we only found it when the snow melted. This is why it's so important that the customer follows our loading plan to ensure there's nobody's going to get hurt while these large piece of product moves on the rail. Okay, moving on. Bob?
Yeah, okay, going into the loading rules a bit. Loading of both open top and closed cars is governed by the rules and regulations developed by the Railway Association of Canada, Association of American Railroads, and also to a point by the carriers themselves and Transport Canada. Compliance with the RAC loading circles and AAR loading rules is mandatory for all open top cars and loads moving in Canada, as per Transport Canada's railway freight car inspections and safety rules. That's kind of a bit of a mouthful, but that's the title of the safety rules. This would include any loads coming up into Canada from the US and offshore. So all cars moving in Canada have to be loaded to the RAC AAR open top loading rules. This and one of the main reasons for this, it helps Transport Canada inspectors when they go out there and look at the load, they have something to mark it against.
The complete manual of rules governing the loading of commodity on open top cars can be found on the AAR website. These manual, unfortunately, they're all in English. Also, for safety reason, in May 2018, it was decided to provide access to these manual through the AAR website to everyone who requires a copy of the loading plan and the rules. So we want to make sure that everybody can do a safe load. These manual, they used to be, they had to buy for it, to buy these manuals, but now it's free of charge. It's on the website. And the cost to maintain these manuals are now covered by all the Class 1 railroads. Section 1 is all the general rules for all the commodities. It provides the requirements for loading and securing cargo on open top rail cars for safe movement over the North American railroads. This general rule is good for Canada, US, and also Mexico. These rules have been formulated to provide safe movement of cars and commodity from one point to the other destination by using uniform methods of securement, and they are mandatory. They are based on exact studies, applied sciences, and collective industries experience. The other manuals, section 2 through 7, they're all open top loading plan figures. The section 2, it's all metal, including steel beam, plates, aluminum, coils, pipe, and other steel products. Section 3, it's machinery, includes transformer, excavator, cranes, wind turbine, and miscellaneous product not covered in the other sections. Section 4, it's where we keep all the archive loading plans that we are not using anymore due to deemed unsafe or not being used by anyone. So we keep it as a, just in case we have to go back. Section 5, it's all forest product, building materials, could be panel products, logs, lumber, and etc. Section 6, it's all military equipment, mainly US, because the RAC has their own military pamphlet that we have. And section 7 is the open top trailers and container loading plans. I'll show you quickly the link to go to the AAR website. This is the AAR website where you can have a drop down and you see the same thing you just saw earlier, section 1 through 7. And if you want to have a look at a loading plan for metal, you're going to click on section 2. And then it's going to give you the first PDF is the full book of section 2, could be around 300 pages or so. And this book is updated maybe once every quarter. The last time it was updated was August 2020. So it needs to be updated quickly. But down below, it's every loading plan per specific product, per specific car, and it's up to date. If we want to have a look at the loading plan, you choose this PDF. And this is exactly the loading plan that we saw the car earlier, where there was an incident. It's steel plates in a gondola car. So every plan are designed the same way. We have a title. We have sketches with general view of the load. We got alpha that's explaining to us what needs to be done to secure the load. So every alpha item number will provide us with the number of pieces it's required to secure the product. by following the description of each item. And what's mostly important are the notes, which are many times overlooked by the loader and the contractor, which are very important in building a safe load. And all these documents are printable. You can save it and you can make copies, but you have to go back every time to make sure it's up to the latest version. Let me see if I can close this. Whoops. There we go. We also have the RAC car loading rules, which are there. We have many approved figures for movement on Canadian railway, which illustrate how to load various products, same as the AAR. These figures are not covered in the AAR Open Top Manual, as these loads were initially unique to Canada. So they're available on the RAC loading rules. These car loading rules are available on the RAC website in French and also in English. So if I open one, for example, this is the car loading rule in English. It was revised this year, and it's similar to the AR. We got general information, and we got numerous figure that exists in RAC. So if you open one, then you see the figure. All the RAC figures are in colored, and it's similar to the AR. We got a title, a sketch, items, number of pieces, description, and some notes. Bob, are you?
Yeah, the only, did you want to maybe just show the French, or is it necessary?
Start the video.
What's that?
Which video you want me to show?
Oh, well, you showed the link to the English version. I was just going to say the French.
I'm going to see the French.
Well, some people may like to.
Yeah, so we got the French version also on the RAC website. And it's really similar. Figures. So you got your title, your sketch, and your description, how to secure your load on the car, and your notes at the bottom.
Claude, just so you know, your camera is turned off.
My camera's turned off? Okay. There you go. Perfect.
Perfect.
Okay, Bob.
Am I up?
Let me see. I think there we go.
Yeah. Okay. What we're going to get into here, we're going to go back to the railway freight car inspection and safety rules. Just going to quickly go over it, just to kind of want to show you where that one rule is, that 14, I think 14.1 N, and take us to the rule, to the pamphlet there. That's your opening photo, obviously. And 2014 is when it was last updated, but it's still current. And as we slowly go down, you'll see you got your part 1 general, and it cuts through your titles and your, the areas of what you'd be looking for. Part 2 is dealing with axles, roller bearings, plain bearings, car bodies, which is the section we want to go to. couplers and drawbars and draft arrangements and so on and so forth. And basically what it's telling you here is it's what a defect is. And as you can see, if you look at 14.1N, which is just in the, right where Claude is circling it there, it says our car is not loaded in accordance with prevailing AER general rules governing the loading of open-top commodities and open-top rail cars, or a circular from the Railway Association. So basically every car moving in Canada has to be loaded to a figure, as was stated earlier on, but I just want to make sure. A lot of people have a tendency to have a hard time with that because it's a little different down in the US. They have a similar rule, but it only comes into effect when the car goes into interchange. So by a load can actually move across the US on the same railroad, and it's not being held to the loading figures, even though the railroads themselves utilize them because, I mean, they've been tested, we know they're safe and so on and so forth. But in Canada, there's no ifs, ands, or buts. It has to be loaded to a figure. So when it's out there moving, whether it's moving strictly on CNCP or SRY, it has to be loaded to a figure. And of course, anything coming up from the States, if one of the US railroads is shipping a product up into Canada, they should make sure it's loaded to a figure as well. I think that should cover that anyway.
Yes. Mm-hmm.
Okay, rules and regulations. And that's basically dealing with Claude and myself. REC field personnel need to be knowledgeable of the loading rules as issued by Railway Association of Canada, Association of American Railroads, and Transport Canada in order to provide the appropriate interpretation for shippers, members, railways when requested. So we're there as a tool for the railroads and their carriers or their shippers. Okay.
Okay, time for questions. If anyone has any question, we'll take them.
We actually have quite a few questions coming through, Claude.
Okay.
So
Meanwhile, Janet, I'm going to show some more photos, okay?
yeah,
Go ahead.
no worries. How often does Transport Canada get involved in inspecting a load? Is it only after an accident, or is it or do they do random inspections?
No, they do inspection all the time. There's a representative of Transport Canada that goes to see members, the railway members, and they do inspect cars in their yards. They do make comments, and sometimes they'll call Bob and RI to discuss the securement. And if it's not them, it's the railway themselves. They will call and they will say, Transport Canada just came by and they got some questions on specific loads. So they do inspect cars quite often.
Thanks. Why do they still have plain bearings in the rules?
Maybe Bob can answer that one. Bob?
Well, there is still some plain bearing cars out there, few and far between, that's for sure. You will find some on your, obviously your historic equipment, i.e. steam locomotives and the likes of that. But really in normal everyday use, no, you won't find them. You don't find this car, well, that car that just went through there, it had plain bearings, but that was an older passenger car. And, but no, I think some of our snowplows still have plain bearings, but most likely not a good enough reason. But yeah, it's they are antiquated, but they are still out there. You know, it could be on some private railroad somewhere. They may have them, so they're not outlawed. So it's good to have the information there in case you need it.
Thanks, Bob. What if a car is loaded correctly and the load shifts? Who is responsible for adjusting the load?
These type of load shifting. It happened quite often. And what they do, they'll contact Bob or I and ask us if the load was loaded according to the loading plan. Sometimes we have to go back to the shipper and ask them to send us a photo before it left our yard. But sometimes right away we can tell it was loaded properly. So we inform the member our opinion if the car was loaded properly. If it was, then it's not the customer's fault, so they don't have to pay for readjusting the load. And if it's found that it is the customer's fault, they didn't do they didn't follow the figure, they didn't secure it properly, then everything that has to be done, lifting the product, re-strapping the product, that will be at their cost.
Thank you. Hello, Claude. Which loading plans are exclusive to Canada in the book that we have online for our loading plans?
Well, all the RAC car loading plans are all acceptable in Canada. Some of them have also been given to the AAR because we do the same type of testing as they do, and the field shipments also as they do. So if they require some sort of a new loading plan that we have already done all the work, all the testing, we provide them a copy. But if you want to know all the RAC Canadian loading plans, they're all on the RAC website.
There's been a few inquiries as to where they can be found on the RAC website. So I will put the links in the chat once the presentation starts going again.
Okay.
One last question, which I think you've slightly addressed, but this is more specific to winter. Do the AAR loading rules factor in Canadian specific elements such as a Canadian winter?
Well, they do. For example, we may say a car of lumber can be loaded up to maximum weight limitation of the rail car. But during winter time, we tell the customer to give an allowance maybe of 4,000 to 5,000 pounds due to snow and ice. And we do have some figures that does specify that during winter time you have to add additional blocking and bracing. Maybe Bob, do you remember which figure in fact does require that? Is it
yeah, we used to put out actually I don't think we do it anymore, but and this is the railroads put it out. They used to put out an alert in September. I think it was September, November, maybe, yeah, somewhere in that area. We used to put out a notice that, and this was for lumber loads. This was the old figures, they're still out there, but figures 60, 61, 63, 64. Those are figures on flat cars, not center beams. And they were required in the winter months from, like I say, around, it all depended, it varied every year because, like this year, maybe an earlier year for winter, let's say. And it was the application of stub sticks. And they would, in the notice would be from, let's say, November 1st to March 31st, and all loads within that section would require stub stakes.
Yeah, one more item.
Yeah, but we also have on most of our figures, it's written in there, that the decks are going to be cleared of ice, snow, and debris. So, which kind of covers it. But we do prefer, when we're testing cars, though, for figures, we do prefer to get some winter testing in there, because obviously winter and summer is completely different, as far as what happens on a rail car.
No, that's great. We have two more questions, and then I think I'll save the next round of questions for the next Q&A portion. What are the railway conductors' responsibilities with respect to improperly loaded cars?
Well, every time there's a car interchange from one carrier to the other carrier, the carrier that is receiving it is also inspecting the car and the load. And if they found a car which is unacceptable, not loaded properly, usually they will return the car back to the carrier that provided the car and ask them to get the car fixed. It happens sometimes that the car will be interchanged, and before the railroad is able to see it, it may have traveled maybe 40, 50 miles. So then sometimes there's arrangement that will be done that the carrier who has the car on end will arrange to have the car fixed by a contractor and charge the customer accordingly.
Thank you. Last question for this round. Where is all the testing done by the RAC? Is there a specific testing location?
Well, yeah, I'll take this one, Claude. Pueblo is there, used to be, I think that's changing, but Pueblo was the main testing, or where their staff was. And they did have a VTU table there. They had a place to do impact testing and so on and so forth. But most of today's testing nowadays is done on the various railroads. Usually, a new figure is brought up usually by the shipper himself. He's got a product he wants to move, and he works with the railroad, and they come up with a figure for it, and they'll test fairly close by, either in the closest large town where there's a rail yard or something like that. So really, the testing is done all over the map in North America nowadays.
Awesome. And I think you guys explained a little bit further about some other testing toward the end of this presentation. So with that, please continue.
Okay. So safety. The mechanical team serve its members and their customers by promoting safe loading procedures and practices. Safe and efficient loading of rail cars is important to both the railway industry and their customers. Each year, the mechanical team inspects thousands of cars at various locations for various commodities, and the inspection of loads are done at the railway yards, customer facilities, and the interchange points, and we do talk to the local carrier and make sure they have the proper loading figures on hand, and also the rules and regulations are being followed. So RAC promotes improved loading practices through training to members and shippers within the industry for domestic and international traffic moving by closed and open top cars. Loads, especially on open top cars, must be secured in a manner that will maximize damage-free transportation of commodities and ensure a safe railway operation. We also provide assistance to shippers and railways members in developing new loading patterns or revision to existing rules and figures, and we get quite busy in a year. I think we're the committee which is the really busy, that we do a lot of changes versus any other committee at the AAR. Open top training, this is another aspect of our duty that relates to provide training. Education is a continuing process due to equipment and personnel changes, as well as evolving rules and regulation and methods. Training is done in class and also on the site in the yard. So we talk about weight, load distribution on the rail cars, load restraints, which is required for longitudinal, lateral, and vertical. Type of securement available for blocking metals could be chains, could be straps, could be cables. Procedures for measuring loads, calculating the combined center of gravity. So it's the gravity of the rail car plus the product, and we combine that, and it should not exceed 98 inches above top of rail car, above the top of the rail. And also how to measure loads when they have overhangs. Bob?
Yeah, what we have here is just in section 1, which is your general rules, and anybody that's doing any amount of loading should become familiar with section 1. It gives you all the ins and outs of the various materials that you're going to apply to restrain the load. One of the most, I think, one of the most important rules in there, because it gives you the springboard of what you're going to do to that load to secure it is the rule 5.3, and that's the load restraint requirements. And what we go by here is the G-force to yield. And in longitudinal, it has to be 3. So 3 Gs, or 3 times the weight at each end of the load. So what you do is, and when we say 3 Gs, if you look on the other side of the graph there, it's actually 6, because you got 3 in each direction. And the same goes for the lateral, it's 2 Gs. And vertical, you get a bit of a break here because most cars are lighter than the actual load itself. So, you either 2 times the weight of the car or 2 Gs. So, but yeah, you do your multiplication here, and now with that, you can start figuring out what you need for cables, blocking, welding if you're welding. One little note though, you're not allowed to weld a load to a car. So it has to be a mechanical bond. You can weld to the piece, or you could weld to the car, but then the other end of that securement has to be bolted or along that line. So you can't weld to the car. But if you take anything away, this is an important rule 5.3. So that's a good one to keep in the bank.
I agree, Bob.
Okay.
What's coming in a couple of years is that the Class 1 railroads are requesting that the shipper add additional information on their electronic data interchange on their wear bill. So they want them to add the loading figure and maybe the section of the product they've loaded. So everyone who's concerned in operation or car inspector, they know what loading figure they use to secure the product. So that will assist them to, whenever there is a dispute or a shifted load, they can go back to the customer and tell them if he loaded the car properly. Again, if you have any question, maybe that's the time to do so. We'll show you some more photos of loads in gondola cars and center beams. Most of the center beams are loads that we have developed at the RAC. RAC, I think, has been promoting more versatile product loaded on center beam versus other carriers in the US.
Bob, Claude, we have one question. For dimensional load planning provided by the RAC, how is the cost calculated and who is the main contact for quoting and information?
Want to take that, Bob?
Well, yeah, I'm trying to understand what the question was. Is it
There's a bit of a follow-up that's kind of joint. Does the RAC also provide securement engineering and or planning? And if so, how is the cost measured and calculated?
Well, yeah, we do provide. We don't do the engineering. We provide basically for an open top load, how to secure dimensional load. We assist the shipper. The shipper is the one that has the really the smarts on the product. He knows how it's got to be secured, where you can secure it to. It's not much sense tying the cable to something and then you end up tearing that that tie down section off. So we rely on them to come to us with actually how it's going to be secured. And then what we do is we'll go over it with them and assist them in, giving the yays and nays to it, or maybe we should change it here, add this or that. But as far as the charge goes, we don't usually charge for that. We do it basically on behalf and at the request of the railroad. Very seldom they'll come directly to us.
I think there's sort of two things here. As an associate member who are mostly suppliers, perhaps you can explain how you work with associate members versus railway members. I believe Within the railway member category, this service provided by the mechanical team is free of charge. But I think for associate members, there is a fee. And I think that may be where the question stems from.
Okay, well, I don't know, maybe Claude can help here too, but like I say, we provide assistance because what we want, our main goal, at least in this side, is not the coin, it's safety. We got to make sure that load is safe for that carrier to carry. You know, that's our goal, is just safety, to be honest with you. So we'll work if we can. And I don't know if where we've charged for doing assistance on dimensional loads, to be honest with you.
Right.
So,
Usually we don't charge unless it's a training which is outside or the normal request. If it's something that an associate member is working closely with a member, the member will come to us and say, we need your assistance to train a few personnel from the associate member, and then there won't be any charge. So it depends what it is exactly, and we do charge on occasion associate members on specific training, and it's not a specific charge cost. So we need to verify where is the training going to be done, do we need to travel, and how many days, and so on and so forth. So it's difficult to answer that question.
Okay, fair enough. Oh, wait, we have one more question. Hi, where can I find the official information about clearance plate with pictures?
Section 1.
Yeah, Section 1 has all the plates for every type of car, and we'll show you one in just in a few seconds or a few minutes. There are 4 or 5 slides, and I'll show you a plate C where it gives you the dimensions of a boxcar. But there's other plate that exists, and it's all in Section 1 of the AAR book.
Great, and I think that concludes our questions for this segment.
Okay, so Bob is going to show you an impact test, and what do we mean by an impact test? So Bob, can you explain them? And you let me know when I run the video.
Well, you can start at any time,
Yep.
because it's going to go in the background as we chit chat. Yeah, what we do is an impact test. We're testing, when we're doing an impact test, what we're doing is we're testing the securement of the load to the car. We do it at intervals of, we do a 4, 6, and an 8. And those are the impacts. And what we do is we drop, for instance, this load here, we'll drop it into what we call the anvil, which are the 5 or 6, or buffer cars in this case, 5 or 6 cars, and they have to weigh up to 250,000 pounds. Air brakes and hand brakes applied. So you're dropping a load into basically a solid lump. And like I say, you got a 4-mile-an-hour impact. 4 is pretty benign, you know, you don't see much action, just kind of snugs things up a bit. Where it gets lively is when you get up to the 8 mile per hour. And then when you do your reverse 8, that's when usually things let loose on you. There's your 6, and you can see it didn't move too much. And again, that's a center beam car. And we take various measurements of, you know, how much the load's shifted. You know, when we mark it up, you can see the chalk marks on there. We also mark how far the buffer's gone, you know, because you can usually tell by reading. Claude and I read impact tests done by other groups, and you can tell by how far the buffer car's gone if actually it's being done correctly. You know, and brakes applied and so on and so forth. And I think that was the 8, and you can see that really survived quite well. 8.6. Yeah. Like I say, the reverse 8 is the one that shows you 6, or tells you the story. This is the reverse. And here comes the reverse 8, and again, this one still survived pretty good. most times if you got a good load, it ends up back to where it started. What you have, I think we lost an encircling band here, a tie-in band, but other than that, the load survived really good. What we've been working at hard at the RAC is to find figures that we can apply to these center beam cars, because most of the time, similar to, let's say, a container, they come back empty from dropping off their load of lumber. So we can find a figure that we can use that goes in the opposite direction. It's great, you know, or product, I should say. Here's another test. This is a load of plate. And these were done in Seattle. We did 5 that day. This is the last car, last switch, reverse 8. And everything went good right up until here on every load except for, and you'll see it happening here pretty quick. And what caused the issue was the corner protectors. They weren't the proper corner protector. He ran out of the correct supplied corner protectors, and these corner protectors cut the strap. So it's a good load if, again, the right materials are used. So in this case here, the wrong material was the corner protection. It's just like having a dozen or so knives out there slicing the cables. So it failed, and of course we know why it failed. We corrected it and went on from there.
Here, I'm going to talk a bit about the National Research Council. They're the largest federal research and development organization. NRC conducts research, development, testing, and evaluate activities for the rail freight, passenger, and ground transportation sector. Their facility in Ottawa is certified by the AAR. The photo on the left, it shows a tow car, which is part of a military vehicle, which is installed on a flat car. And we're going to do an impact test for that specific tie down of that piece using their ramp, which is a small hill, where they're going to do an impact test. With this one, I'm going to show you a quick video. And the photo on the right, it's their speed recorder when they do hit the buffer cars with that impact test. Here's the video of the impact test done at the NRC in Ottawa. So with the tow car, they bring the car up the ramp at a certain location, and they know at what speed it's going to be dropped to the cars on the right-hand side. It's the buffer cars. So here's an example of the reverse 8 at the NRC in Ottawa. As simple as that. The military, they do often do their impact tests at the NRC. So every time they do it, they call upon us to be there and take all information and provide a final result. We may take more questions, or I think Bob, we're going to go. There's not too much time left. We'll go to the dimensional load, Bob.
Oh yeah, okay. I was just looking for the section that had the plates for the person there that was asking.
There we go. This is the plate C on your right-hand side of the slide. I don't remember the what section exactly, but it's
between 5, 6, and 7 somewhere.
Okay.
Yeah, basically what we got here is a dimensional load. And in Canada, anything that's either 12 feet in height, and that's the load itself, so the transformer in this case, or exceeds 15'6". And if you look at the drawing on the right, you'll see 15'6" is the height from top of rail to the top of the roof of, or in this case, this opening, that's 15'6". So anything above that is considered a dimensional load. Or has a combined center of gravity that exceeds or meets or exceeds 98 inches. And we have issues with center of gravity. If you remember, if you think back in beginning of the presentation, we had a load where a transformer was laying on its side on the rail car. And what happened there is it did have a high center of gravity. It was known to have a high center of gravity. Actually, the load was secured quite well. As you've seen, it didn't fall off that flat car. But what it is they stopped the train, and it was said so in the instructions not to do so. They stopped the train on an elevated curve. And of course, when they went to leave, it just rolled over and died on the siding. They just flopped over. And that's because of the high center of gravity. But anyway, so that's plate C is usually if you load a car within plate C, you're pretty well guaranteed it's going to go anywhere in North America. That's our base guide. Once you start going outside of plate C, you got to go to your clearance bureaus of that railroad and get permission and get clearances for it. Yeah, any shipment that falls into any of these categories may be considered dimensional and will require pre-clearance from the carrier. Also, the carrier, once if you're shipping your product, let's say from let's say Thunder Bay, which a lot of big stuff comes in at Thunder Bay, and you're going into the southern states or Mexico, whether it be CN or CP that moves that product, he has to clear it all the way down to destination, final destination. That's their responsibility. It's not much sense just clearing it to the Canadian border if it can't go any further. So it has to be cleared all the way through its travel. Here, what we have here is on the left-hand side is the clearance form that we put in when we measure a load. And why I say we is either be RAC if we write it up, it'd be CNCP. It's a generic one that was designed, and it's got all the information on the rail car. And on the top, the date it was shipped or inspected, the location where it was coming out of. This one here was coming out of Thunder Bay. Car initial, car number, light weight of the car, load limit of the car, the width of the car deck, and the height of the car deck. And it's origin Thunder Bay, and this one was going to Amory, Manitoba. The shipper is listed there, and so on and so forth. Down below, though, where it says load measurements, that's where we start off with the calculations of measuring the load. And what you do when you measure a load, you measure from the center of the car, the center, so we call it, the center line of the car, of the deck. And we measure out to the widest point on the right side of the car, and then we measure out on the left side of the car. And they don't always go the same. You know, you may be, like, say 5'6" on the right side and only 5 foot on the left side. So what you do is you double the 5'6", and that gives you your width of the load. In that case, would be 11 feet. And that's how you measure load. You double everything. You go from the center. And the reason for that is you never know if the car is going to get turned around. Doesn't happen as much these days because you don't have Ys and turntables as much as you used to, but it can happen, and if it does, it could be quite a surprise. So yeah, cut me off, eh?
Yes, I did. Sorry, there's not much time left. So just to really finalize, this is the last slide. The RAC mechanical group is here to assist you guys. Thank you for attending today's Lunch and Learn. We look forward to working with you in the future. Do not hesitate contacting us if you have any questions or concern. I think you have to involve us as soon as possible before the project is almost completed. We need to be involved at the beginning so we can help you with the proper car, the proper securement plan. But if you have any more questions, we'll be happy to answer them.
But why didn't you leave that video going there, Claude? Well, it's
Dimensional loads, okay. Janet, do you have any questions?
No, it's quiet on the question front right now. We'll just give it maybe a couple seconds to see if anybody is typing. We have some comments coming into the chat. Claude and Bob, we got a comment, great presentation. For RAC members, this will be posted on our news and events section of our members only website. So you'll need your login credentials to access it after this, but just to let you know that it will be available online on the RAC members only site.
Okay, and the person that was asking about the plates, where to find them, which was section 1, and you go to section 1, appendix A, and they're all in appendix A.
Thanks, Bob. I'm going to quickly launch the poll right now. You'll see it up on screen. There's 3 questions. You may not be able to see the full questions on your screen, but on the right-hand tab, there's a scroll down button where you can submit your answers. So please feel free. We'll have that up for the next minute or so while you can watch the dimensional load videos. Oh, I think we do have a question. We have a question. Hi, Vince. Any charge for impact testing?
Yes, there is. If they go to the AAR, it could be quite expensive because you have to bring your load to the US, possibly to Colorado. If you do it in-house, you could, if the customer has a long track and he's got the locomotive or local tractor, he's able to push the car. We could do it at his site. Of course, it's very much less expensive. It's just time and getting the stuff ready. As far as doing the impact tests, RAC, we do not charge. We go there, we take care of everything, the documentation, the filming, the notes, and the follow-up. So there is cost if you do it outside the customer site.
Thank you. Just being cognizant of time, we have one more question that came through, and I'm very curious to know the answer because I don't know what this is relevant to. Do you still use torpedoes in impact testing?
Bob, do you know?
Yeah, you can still use them. You know, you can use a stopwatch. Torpedoes are still there, but no, you know, within modern day, we got radar out there, and radar's the most accurate way of doing it. So, but I believe they're still out there somewhere. You know, I mean, they are still in the units or the engine. Let's say they're still up there, and they have been used. The last time I used them, it's got to be 30 years ago. So, yeah.
That's great. Well, that was our last question, gentlemen. And once again, on behalf of the RAC, thank you to all members and associate members for attending today's mechanical services. And thank you to Claude and Robert for giving a great presentation today. And everyone stay safe and enjoy the rest of your week.
Yeah.
Bye, everyone.
Thank you.